Hi. We will be revising exercises 6.1 and 6.2, rate of change of quantities. So dy by dx means how fast y changes as x changes, that is with respect to x, that is dy by dx. Dx by dt means how fast x changes with respect to t. Okay. Now see page number 196, that blue box. So dx by dy will be positive, or dy by dx will be positive if as x increases, y also increases. Okay, if both are increasing or both are decreasing, as x decreases, y decreases, say, then dy by dx will be positive. Similarly, if as t decreases, x decreases, or as t increases, x increases, dx by dt will be positive. If it is the other way around, that is, x is decreasing but y is increasing, say, so we take it as negative quantity. Okay. Similarly, as dx by dt, as t increases, x decreases, say, then we have to take it as a negative quantity. Okay, that's what it is given in that blue box. Dy by dx is positive if y increases as x increases, and is negative if y decreases as x increases. One should decrease and one should increase. Now, if you see exercise 6.1, look at the first question. Very simple questions there. Find the rate of change of area of a circle with respect to its radius. Respect to its radius means you have to differentiate a with respect to r. So you will be calculating dA by dr, not dA by dt. Okay. Whereas second question, look at the unit, 8 centimeter cube per second. So since it is per second, you have to differentiate with respect to t. And that 8 centimeter cube per second or 12 centimeters should be substituted after differentiation. All the values should be differentiated after differentiation. So you should be thorough with all the mensuration formulae. And look at page number 198, question number 7. So the length of a rectangle is decreasing. So in that case, we have to take that as dx by dt as minus 5 centimeter per minute, because it is given as decreasing. And y increases, so that means dy by dt will be plus 4 centimeter per minute. So please practice that question. It is an easy question, but you practice that. Then go through all the other questions. 10th question we will do now. Question 10. A ladder 5 meters long is always, leaning against a wall. So this is the ladder which is 5 meters long. The bottom of the ladder is pulled away from the wall. So that means x changes. So the rate at which you are pulling the ladder, the foot of the ladder, is the rate at which x changes. So it is 2 centimeter per second. And then how fast is its height on the wall decreasing? So we have to calculate dy by dt. Since it will decrease, the answer will be negative. When the foot of the ladder is 4 meters away from the wall, so x is equal to 4 meters, it is given, which is 400 centimeters. And length of the ladder is given as 5 meters, which is 500 centimeters. So since these two quantities are given, we can calculate y using Pythagoras theorem, which is 3 square 3 meters, which will be 300 centimeters. I am converting them to centimeters because dx by dt is given as 2 centimeters per second. That's the reason. Now we need a relation between x and y, so I am going to use Pythagoras theorem as it is a right triangle. We know that x square plus y square is equal to 5 square, that is 25. Now I am going to differentiate with respect to t. Differentiating with respect to t, 2x dx by dt, both x and y are variables, so both should be differentiated with respect to t. Power has to be differentiated first, then the base y has to be differentiated with respect to t. 25 is a constant, so the answer will be 0. I can divide throughout by 2. Now all these values should be substituted only after differentiation, I have told you. Okay, but 500, length of the ladder is a constant that can be substituted, so that's why we used 5 square here. Now I am substituting for x and dx by dt. Y is 300, we have calculated. Dy by dt we don't know, we have to calculate that. So dy by dt will become minus 800 over 300. The negative sign indicates that it decreases. Y decreases as t increases, and the unit will be centimeters per second. So you have to write the height of the ladder on the wall decreases. If you use the word decreases, then you need not write the negative sign. Decreases at the rate of 8 by 3 centimeter per second. You have to write the answer like this. Okay, go through all the other answers, and then 13th. I am changing the board. Question 13. A balloon which always remains spherical has a variable diameter. The given quantity is a diameter. So we can find the radius. So radius will be, you have to divide by 2. So it becomes 3 by 4 times 2x plus 1. Find the rate of change of its volume with respect to x. It is given in the question clearly that you have to differentiate with respect to x. So volume of the sphere formula is 4 by 3 pi r cube, but r is given, we will substitute. So 3 cube is 27, 4 cube is 64, and 2x plus 1 the whole cube. We have to differentiate the volume with respect to x because it is mentioned in the question. We have to differentiate the volume with respect to x. Now this is 9 times, this is 16, 9 pi by 16 is a constant. Keep it outside and differentiate the power first and then the base. Differential of the power is 3 times 2x plus 1 whole square. When you differentiate the power, the base has to be kept as it is. Now base has to be differentiated 2 into differential of x with respect to x it is, so 1. It is 27 over 8 pi 2x plus 1 the whole square. That's the answer, and unit is not given. So you can write it as unit cube per unit. Fourteenth question. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. That means dV by dt is given. You can make out from the unit. It is 12 centimeter cube. Centimeter cube is volume unit. S is time unit, seconds. So dV by dt is given. So when you pour the sand on the ground, it forms a cone. So as you keep pouring the sand cone increases. So R, H, V, everything is a variable here. We have to substitute all these values. Varying quantities should be substituted only after differentiation, not before differentiation. Okay. And when the height of the cone is always 1/6 of the radius of the base. It is given in the question. So R will be 6h. And how fast is the height of the sand cone increasing when the height is 4 centimeters? So we have to find dH by dt. Let us use volume of the cone formula, 1/3 pi r square h. Don't do mistake in the formulae, memorize them properly, which is equal to, now we have two variables. We can do with two variables, but you will have dr by dt, which we don't know. We can find using this, but substituting and changing it in terms of one variable will be better. Since we need dH by dt, we will keep the variable h. We will eliminate r using this relation. That relation is given. R is 6h, so whole square, 36 by 3 pi, h square into h square we have here, and into h becomes h cube, and 3 and 36 I can simplify. Now let us differentiate with respect to t. 12 pi is a constant. H cube has to be differentiated, power has to be differentiated first, then h has to be differentiated with respect to t. Now substitute all the given values. All our variables I said, r, h, v, everything. So we have to substitute only after differentiation. This is 12. 12 pi times 3 into h is 4, 4 square 16. dH by dt we don't know. That's what we are going to calculate. 12 gets cancelled. So dH by dt is 1 over 48 pi. So dH by dt is 1 by 48 pi, and the unit is centimeter per second. So you can write the answer in words. The rate at which it changes, the height changes with respect to time is 1 by 48 pi centimeter per second. And then 15, 16, 17, 18. Marginal cost or marginal revenue. If the word marginal is given, say, whether it is marginal cost or marginal revenue, you have to find the first derivative and substitute the value. You will get the marginal cost or marginal revenue. And I told you to practice question number 7. Okay. And other questions you may go through the answers. That is enough. And we have, look at the miscellaneous exercise. Page number 242. Page 242. Third question. Two equal sides of an isosceles triangle. This is an isosceles triangle. These two sides are equal. With fixed base. That means base is a constant. B is a constant. Let the sides, equal sides, be x each. X is a variable here. We don't know what is the length of the, what are the lengths of those equal sides. Fixed base B are decreasing at the rate of 3 centimeter per second. The equal sides of an isosceles triangle. So dx by dt is given 3 centimeter per second. How fast is the area decreasing? So we need to find the area. I am drawing an altitude to find the area of this triangle. This is an altitude. So we know that in an isosceles triangle the altitude bisects the base. So this will be b by 2. So height of the triangle will be root of Pythagoras theorem I am using minus b by 2 the whole square, which is b square by 4. This is the height. Now area of the triangle is half into base is b, the whole thing is the base, into height is root of x square minus b square over 4, where b is a constant, remember that. Now we will differentiate with respect to second, per second is given, so we are going to differentiate with respect to time. So dA by dt is equal to half into, b is a constant. See, we can square and do it, but I told you only in maximum minimum question we do that. Here you can square it, but if you square you will get a square. Differentiation will give you 2a dA by dt. We have to find dA by dt. We don't know the value of a. Okay, that's why we are not squaring here. So half into, I have to use, b is a constant, right? Okay. So no product rule required. So b by 2 is a constant, take it out. I have to differentiate this part. Power half it is. So let us differentiate the power. So it becomes half into x square minus b square by 4 whole power n minus 1, that is half minus 1. Half minus 1 is minus half. So I have differentiated the power. Now I have to differentiate the base, that is this. Differential of x square is 2x and that is a constant. B is a constant, so 0 it is. Second term is a constant, so differentiation becomes 0. This is equal to, I can cancel this too. So it becomes b by 2. I can write this in the denominator. Okay, now we have to find how fast is the area decreasing when two equal sides are equal to the base. That is, equal side is equal to the base means x is equal to b. It is not 2x is equal to b. Okay, don't do that mistake. Equal sides means x we have taken. So x is equal to b is given. We are substituting now. So it becomes b square minus b square over 4, which is b by 2 times, take LCM. So it is 4b square minus b square. This 2 and root 4, which is 2, will get cancelled. So it is b by root 3b. So the answer is dA by dt is equal to 1 by root 3 times, unit will be area. Area unit is centimeter square per second. This is the answer. Now 19th question of miscellaneous exercise, page 243. This is a little different question. Here the container is cylindrical and the radius of the container is 10 centimeters. You are pouring wheat into it. As you pour wheat, the level rises, right? The radius remains the same because it is a container. The radius of the container doesn't change. So the radius of the that wheat's cylinder doesn't change, right? So you have only height is a variable here. As you keep pouring, height of that wheat changes, right? Okay, so R is a constant. We can substitute at the beginning itself. This is a little different from the other questions. I have been telling you the values which are given should be substituted only after differentiation. Okay, but those are varying quantities, like the sand cone we did. R is a variable. As you pour sand, it forms a cone on the ground. As you keep pouring, the sand cone increases. So radius is a variable here. Height is a variable. V is a variable. So varying quantities should be substituted after differentiation. Whereas here radius is a constant. So we can substitute at the beginning itself. Okay, radius 10 meters is being filled with wheat at the rate of, so dV by dt is given 314 cubic meters, meter cube per hour. Then the depth of the wheat, that is dH by dt, we have to calculate. So volume of the cylinder is pi r square h, but r is a constant, so I can substitute r as 10, so r square will be 100. As it is a constant, I have substituted, otherwise you have to substitute only after differentiation. This is equal to, I am differentiating with respect to t, so it becomes dH by dt, which is equal to, I can substitute the value of dV by dt, and I can substitute the value of pi. We usually don't substitute the value of pi, but here it is 314, we can simplify further, that's the reason. So it becomes dH by dt equals 1, because this is also 300 into 3.14 becomes 314, and the unit is meters per hour. This is the answer. Page number 235. Example 43. A water tank has the shape of an inverted right circular cone. The tank is in this shape, with its axis vertical, the vertex lowermost. Semi-vertical angle means half of this vertical angle is, that is alpha is tan inverse of 0.5. That means tan alpha is 0.5, that is 0.5 is half. Water is poured into it at a constant rate of 5 cubic meter per hour. That means dV by dt is given. From the unit you can make out, cubic meter is volume unit per hour. Find the rate at which the level of water is rising at the instant when the depth of the water is 4 meters. Okay. So as you pour water into it, the water level rises. So h of the water cone, height of the water cone is a variable, radius of the water cone is a variable. Both are varying quantities. So you have to substitute these values only after differentiation. Okay. Now, volume formula is 1 by 3 pi r square h. We have two variables, so we have to change it in terms of one variable. So we have to find dH by dt. I am using tan alpha. Tan alpha is opposite by adjacent, that is r by h. Tan alpha is given as half. Okay. Now volume is, I am leaving one line because I have to decide for which variable I have to substitute. Of course, we have to eliminate r because we need h in our answer. We have to find dH by dt. So volume of the cone is 1 by 3 pi r square h. So I am eliminating r, h by 2 the whole square, which becomes pi by 2 square is 4, 4 3s are 12, and h cube. Now let us differentiate with respect to time. Pi by 12 is a constant, take it out. Differentiate the power first and then the base with respect to time. Now substitute the given values. H is given as 4, so it becomes 16, and dH by dt we have to find, and dV by dt is given as 5. So this is the answer, 5 by 4, 5. So dH by dt equal to 5 by 4 pi. And the unit is meters per hour. This is the answer. They have substituted the value of pi as 22/7. Okay, now example 44. This is the lamp post. This is the man. A man of height 2 meters walks at a uniform speed of 5 kilometers per hour away from the lamp post. He is walking in this direction. If I take this x, as he walks away from the light, x increases. So that is his walking speed. So dx by dt is his walking speed, which is 5 kilometers per hour. Okay, the length of the shadow will change as he moves. So this is his shadow. Let the length of the shadow be y. At the beginning you have to write what is x and what is y. Y is the distance between the man and the lamp post, and y is the length of the shadow. Whatever variable you are using, you have to define it. Length of the shadow. Okay. Now we need a relation between x and y. Since we have two triangles here, we are going to use similarity. I will name the triangles A, B, C, D and E. Mention that the triangles are similar. ABC similar to triangle ADE. So corresponding sides must be proportional. 2 corresponds to 6. Y corresponds to x plus y. Here you have to be careful, it is x plus y, not y. So if you cross multiply, you get this. Let us simplify. This is the equation. This is the relation between x and y. Now let us differentiate with respect to time. So dx by dt is equal to 2 dy by dt. Dx by dt is given. Okay, here this is given in kilometers. The length of the man, and this is given, and we need not change here. We need not change because we are not going to use 2 and 6 here, right? So dx by dt is 5. 2 dy by dt. dy by dt is equal to 5 by 2, which is 2.5 kilometers per hour. So you have to write the answer in words. Therefore, the rate at which the length of the shadow increases is 2.5 kilometers per hour. Next is increasing decreasing exercise. It is an important exercise. I am changing the board. So the first step is we find the critical points. Critical points means where f dash is 0 or where f dash is not defined. Both are critical points. The second step is domain has to be split into intervals. This is our second step. First step is finding the critical points. Second step is splitting the domain into intervals. Third step is in each interval we have to check by taking a test value. We have to substitute an f dash for checking. So according to the slope we decide. If f dash is positive, we say that it strictly increases. If f dash is negative, we say that it strictly decreases. And you should know where to include the word strictly or not. When we do the questions, I will explain. For example, at a value it becomes 0, f dash is becoming 0, and you can write it as a closed interval, but you cannot use the word strictly in that case. Okay, now you are going to practice 6th question, CE subdivisions. Polynomials are easy questions. I will do the 7th one now. So y is log of 1 plus x minus 2x by 2 plus x. Here the domain is mentioned. If the domain is not mentioned, you have to find out the domain. Because of log function, log is defined only for positive values. That means 1 plus x should be greater than 0. That's why x is greater than minus 1. Okay, and the denominator should not become 0. That also you have to consider. But that doesn't come under this interval, so no problem. Domain is given in this question. If it is not given, you have to find the domain. Now let us differentiate. Differential of log is 1 by 1 plus x into differential of 1 plus x is 1. Here we have to use quotient rule. U dash 2 into v minus u v dashed is 1. 1 by 1 plus x. I am opening the brackets. Which is equal to you can take LCM or you can equate it to 0 also. So 1 by 1 plus x equal to 4 by 2 plus x the whole square. I am cross multiplying. Opening the brackets. We get x square as 0. That is x as 0. So the domain was minus 1 greater than minus 1. So minus 1 to infinity it was, and we have 0 here. So we have two intervals. So the domain has to be split into intervals 0 to infinity. Now in each interval we have to check. Intervals, sign of f dashed and nature of f. We have only two intervals in this question. You have to show at which test value you are checking. So I am taking minus half, which is equal to, I am going to simplify here. You could have taken LCM, it would have been better for checking. Okay, anyhow. It is 1 by 1 plus 1 minus half. 1 minus half is half, so it becomes 2. Half in the denominator, so if I write the reciprocal, it is 2. So 4 by 2 plus half, that is 2 and a half, 5 by 2. 5 by 2 is 20, 5 by 2 whole square is 25 by 4. So if I write the reciprocal, it is 16 by 25. So this is a fraction, so it is positive, greater than 0. So I can use the word strictly, but here the word strictly is not mentioned. Okay, anyhow, let me use strictly increases here. And then here I am taking the test value 1. I am substituting it here. 1 by 1 plus 1 is half, minus 4 by 3 square is 9. So if I take LCM, it becomes 9, 18 is the LCM, 9 minus 8, so positive, greater than 0, so strictly increases. Okay, but look at the question, the word strictly is not mentioned. So I can write it as 0 to infinity, minus 1 to infinity. I can combine because in both it is increasing. If I combine, 0 is included, no problem, because at 0, look at that, at 0 f dash is equal to 0. Okay, so in this interval f dash is greater than or equal to 0. That's why I cannot use the word strictly. So in this interval f increases, I can say. I cannot use the word strictly because at 0 it becomes equal to 0. Okay, this is the answer. Because the answer is asking for increasing, you have to combine and give the answer. Okay, practice 6, C and E I said, 8th question also you practice. Now we will do the 9th one. Question 9. Y is 4 sin theta by 2 plus cos theta minus theta. And the interval given is closed interval 0 to pi by 2. Okay, let us differentiate to find the critical values. The whole square, u dashed 4 cos theta into v. U dashed is 4 cos theta into v I have written minus u and v dash. Differential of 2 is 0 and differential of cos theta is minus sin theta. And many will forget this theta. The differential of theta with respect to theta it is, so it becomes 1. I have changed it as theta here. Now let us open the brackets. Plus it becomes which is equal to 8 cos theta. I can combine these two terms, sin square plus cos square. If after taking 4 out it becomes 1 minus of 2 cos theta the whole square. I have taken LCM. So 8 cos theta. I'm opening the brackets because we have in between minus sign, please use brackets. Plus cos square theta. No need to expand the denominator. Keep it in this whole square form. Whole square is always positive. Easy it is. 4 gets cancelled. And here for 8 cos theta minus 4 cos theta is 4 cos theta minus cos square theta. 2 plus cos theta the whole square. I can take cos theta out. 2 plus cos theta the whole square. Now a complete factorization I have done. I have to equate it to 0. Cos theta equal to 0 is one solution. Cos theta equal to 4 is the other solution. This is not possible. I have told you, whenever you write not possible, you have to write the reason. The reason here is cos theta lies between minus 1 and plus 1. Never it takes the value 4. Now here, cos theta is 0 at pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2, etc. But look at the domain. The domain is only the first quadrant, 0 to pi by 2. And we have only one answer, pi by 2. That means I cannot split this interval further. The domain cannot be split. I didn't get any in-between value to split the domain. Now let us check in this interval. In this interval, I cannot substitute pi by 2. I cannot use pi by 2 because f dash will become 0. Okay, f dash will become 0. So don't use that. I can use 0. I should not use pi by 2. Because we didn't get theta as 0 as the answer, right? The answers which you got, critical points, you should not use those points for checking. So f dash of 0, where I am going to substitute here in this step. In f dash I have to substitute cos 0 is 1, 4 minus cos 0 is 1, and denominator is positive. I need not even check, so it is positive. So actually f dashed is greater than or equal to 0 in this interval, because at pi by 2, look at this critical point, at pi by 2 f dashed is equal to 0. So f dashed is greater than or equal to 0 in this interval, so I cannot use the word strictly. The question also doesn't have the word strictly. Therefore, f increases only I can write. If I use open interval, I can use the word strictly. Open interval here especially, pi by 2. Here it is okay for 0. Increases in 0, pi by 2. We will do another board question, but polynomials are very easy. You can do by yourself. So we will do one trigonometry question. I am changing the board. F of x is equal to sin x minus cos x, and the interval is 0 less than x less than 2 pi. Is increasing or decreasing? They don't give the word strictly here. Increasing or decreasing? This is a board question. Let us find f dashed of x. Differential of sin x is cos x. Differential of cos x is minus sin x. So it becomes plus sin x. Now cos x is equal to minus sin x. So tan x is minus 1. Or cot x is equal to minus 1, you can write. Tan is negative. 0 to 2 pi is all 4 quadrants, one full rotation. Tan is negative in the second and in the fourth quadrant. So I will get 2 answers. My base angle is pi by 4 because of 1 plus 1 pi by 4. So second quadrant angle should be written as pi minus pi by 4, and fourth quadrant angle is 2 pi minus pi by 4, which is 3 pi by 4, 8 minus 1, 7 pi by 4. So I have to split the domain. The domains are 0 and 2 pi, they are not included, open interval. So 3 pi by 4, 7 pi by 4. I am writing the intervals, that is our second step. Now in each interval we have to check. So intervals, sign of f dashed, nature of f. I am writing the intervals which we got. Seven pi by 4 to 2 pi. Open. The intervals are all open because it is 0 less than 2 pi here. See? 0 strictly less than 2 pi. 0 less than x less than 2 pi. That's why open interval. If it is equal to closed interval at 0 and 2 pi, you should use. We have one example some in our textbook. Like that. Okay. So f dashed of, I can use pi by 2. Pi by 2 is in this interval. See? I have second quadrant angle. So pi by 2 I can use. I have to substitute in this step. Not tan. Tan we got only after substitution, no? Here. Which is equal to sin 90. Cos 90 is 0. Sin 90 is 1. So positive. I can use the word strictly here, but the question doesn't say the word strictly. Okay, let us see. because I have written open interval, I can use strictly increasing. Okay, then f dash of, I can use pi or 3 pi by 2 also. Cos pi is minus 1, sin pi is 0, so it is negative, strictly decreases. And then f dash of 330 degrees we can take, because 7 pi by 4 is 45 times 7. 45 times 7 is 315. This angle is 315, so I am taking 330. So it is cos 330 plus sin 330. Cos 330 is 360 minus 30, and sin 360 minus 30. So for 2 pi we don't change the ratio, cos remains as cos. In the fourth quadrant, this is a fourth quadrant angle, in the fourth quadrant cos is positive, so it becomes cos 30. Cos 30 is root 3 by 2, and sin is negative in the fourth quadrant, and sin 30 is half, so it increases. Root 3 is bigger than 1, so strictly increases. But in the question the word strictly was not mentioned. It is not mentioned strictly, so I have to use closed intervals. So 0 to 3 pi by 4 closed, because f dash is equal to 0 here. Union, again closed, 7 pi by 4 to 2 pi. 2 pi is open because it is given like that in the question. 0 and 2 pi not included in the domain, so we cannot write closed. So in these two intervals f increases. I cannot use the word strictly because at the critical points I have included the critical points, that's the reason. Then here also I am including the critical points. So in this interval f decreases, I can say. I cannot use the word strictly. Hope you all understood where to use strictly and where not to use strictly. Now you practice one polynomial question, example 47, which is given on page number 238. That's all, you practice one or two.